we physicists have held up for 100 years, starting around 1916, for this photograph. It is a neighborhood black hole that may pleasantly be one of the most interesting and curious phenomena in the universe. They might be significant beasts as far as power, but then basically imperceptible to us. A black hole may be 2 to 4 million times the mass of the Sun. However, due to the assessment that was put into them over the last several years, we have gone from knowing virtually nothing about them to getting to understand them more closely. Remembering that things have gotten more noteworthy, Michio Kaku recently proclaimed that we, at last, have gotten a look at what is inside a black hole. This new reality sheds light on the nuances the universe of science may have missed from the beginning. As we dive further into black holes and uncover what is inside, the region is broad. Before we get into the nuances of what Kaku discovered, we need to discuss the main facts about black holes. Although many people have a general idea of what black holes are, there are still some fundamental facts that need to be emphasized. In 1916, Albert Einstein published his theory of general relativity, which predicted the existence of black holes. At that time, the idea of black holes was almost purely theoretical. It required a further 50 years for the scientific community to find evidence that black holes actually exist. This happened in the 1960s when they were studying the Cygnus constellation. They observed a surprisingly bright blue star that was emitting X-rays. This star was clearly not a dead object but was orbiting a giant dark something. Upon further examination, it was confirmed that the X-rays were not moving on their own but were being sucked into the dark object they were orbiting. They called it a black hole. This discovery was significant because it provided evidence that black holes most certainly exist, beyond being just a creation of Einstein's wild imagination. Following the discovery of Cygnus X1, scientists began to look for other black holes. They found that there might be more than 100 million black holes in the Milky Way alone. Given how difficult they are to observe, we don't have an exact number. From these observations, it is estimated that there are several million black holes in our universe. The primary concern with black holes is always going to be gravity. Their gravitational pull is so strong that anything entering it gets compressed down to a singularity. In more technical terms, black holes act like endless vacuum cleaners that suck everything in. One of the most terrifying aspects of black holes is that if anyone were to fall into one, they would be stretched out until they became a single line. This process would happen gradually, and the person would die before the extreme compression sets in. So no one should ever step into one. The closest black hole to Earth is about 500 light-years away, which is still quite far. In 2021, scientists were able to capture the first clear image of a black hole, specifically the M87 black hole. This black hole was observed over several nights, and with each image, researchers gathered more evidence. They found that there are 3 layers to a black hole, not just a single point of nothingness. The first layer is the event horizon, the point of no return. Once you pass this, you will be sucked into the black hole. The second layer is the photon sphere, where light orbits the black hole. Any light entering this area will be trapped. The third layer is the singularity, where everything that enters gets infinitely compressed. Each black hole is unique, even though they generally follow the same 3-layer concept. Scientists can observe black holes indirectly by seeing the radiation they produce and the gas and dust that surround them. Sending a probe into a black hole is not feasible because anything that enters the event horizon will be pulled toward the singularity and compressed to an infinitely small point. In conclusion, scientists are left with no choice but to observe these objects indirectly. Despite the challenges, research on black holes continues to be one of the most fascinating and important fields in astrophysics. We physicists have waited for 100 years, starting around 1916, for this photograph. It is a neighborhood black hole that may be one of the most interesting and curious phenomena in the universe. They might be significant beasts in terms of power, yet essentially imperceptible to us. A black hole can be 2 to 4 million times the mass of the Sun. However, due to the extensive research conducted over the past several years, we have progressed from knowing virtually nothing about them to understanding them more closely. Michio Kaku recently proclaimed that we finally have a glimpse of what is inside a black hole. This new discovery sheds light on the intricacies that the field of science may have missed from the start. As we delve deeper into black holes and uncover their inner workings, the field of study becomes increasingly vast and fascinating. ###What are black holes? Before discussing the nuances of Kaku's discoveries, it's essential to cover the basics of black holes. While many people have a general idea of what black holes are, there are crucial aspects that need to be understood. In 1916, Albert Einstein published his theory of general relativity, which predicted the existence of black holes. At that time, the concept of black holes was almost purely theoretical. It took another 50 years for the scientific community to find concrete evidence that black holes actually exist. This evidence came in the 1960s while studying the Cygnus constellation. Scientists observed a surprisingly bright blue star emitting X-rays. This star was not a dead object but was orbiting a giant, invisible mass. Further investigation confirmed that the X-rays were being sucked into this dark object, later identified as a black hole. The significance of black holes. This discovery was monumental because it provided tangible evidence that black holes are real, beyond being just theoretical constructs. Following the discovery of Cygnus X1, scientists began searching for other black holes. They estimated that there might be over 100 million black holes in the Milky Way alone. Given how difficult they are to observe, an exact number is hard to pin down. Nevertheless, the presence of several million black holes in our universe underscores their importance and prevalence. The mechanics of black holes. The primary concern with black holes is their immense gravity. Their gravitational pull is so strong that anything entering gets compressed down to a singularity. In technical terms, black holes act like endless vacuum cleaners, sucking everything in. One of the most terrifying aspects of black holes is that if someone were to fall into one, they would be stretched out or spaghettified until they became a single line. This process, known as spaghettification, happens gradually, and the person would die long before the extreme compression sets in. Hence, no one should ever approach a black hole. The closest black hole and recent discoveries. The closest black hole to Earth is about 500 light-years away, which is still relatively distant. In 2021, scientists managed to capture the first clear image of a black hole, specifically the M87 black hole. This monumental achievement involved observing the black hole over several nights and compiling the data to create a comprehensive image. Researchers discovered that black holes have three distinct layers: the event horizon, the photon sphere, and the singularity. Event horizon ***, the point of no return. Once an object crosses this threshold, it is inevitably pulled into the black hole. Photon sphere ***, the region where light orbits the black hole. Any light entering this area is trapped in orbit. Singularity ***, the core where everything that enters the black hole is infinitely compressed. Each black hole is unique, even though they generally follow the same three-layer structure. Scientists observe black holes indirectly by studying the radiation they emit and the gas and dust surrounding them. Direct exploration, such as sending a probe into a black hole, is not feasible because anything entering the event horizon is compressed to an infinitely small point. Challenges and future research. Given the immense challenges, scientists are left with no choice but to study black holes indirectly. Despite these obstacles, research on black holes remains one of the most fascinating and important areas in astrophysics. Advances in technology and observational techniques continue to enhance our understanding of these mysterious objects. Theoretical implications and quantum mechanics. Black holes also play a crucial role in theoretical physics and quantum mechanics. They challenge our understanding of space, time, and the laws of physics. For instance, the concept of Hawking radiation, proposed by Stephen Hawking, suggests that black holes can emit radiation due to quantum effects near the event horizon. This phenomenon indicates that black holes can lose mass over time, eventually evaporating completely. The study of black holes also intersects with the quest for a unified theory of physics, combining general relativity and quantum mechanics. Understanding black holes could provide insights into the fundamental nature of the universe and lead to breakthroughs in our comprehension of gravity, space-time, and the quantum world. Conclusion. In summary, black holes are among the most intriguing and mysterious objects in the universe. From their theoretical prediction by Einstein to the recent groundbreaking observations, our understanding of black holes has come a long way. As scientists continue to explore these enigmatic entities, we can expect even more fascinating discoveries that will deepen our knowledge of the cosmos and the fundamental laws governing it.